Here on Vega Astro, we've talked quite a bit about A-type stars, Sirius, Vega, Altair and Fomalhaut, but they don't end there, they continue on forever into the universe. Two stars next in line are Alderamin or Alpha Cephei and Denebola or Beta Leonis. A-type stars are the last realistic vestiges thought for intelligent life, living just long enough or around 1 billion years on the main sequence for Genesis to occur. Hi everyone, Vega here, and in today's video we continue our Brightest Stars series and take another look at A-type stars. So let's get to it. If Sirius, Vega, Altair and Fomalhaut are a family, then Alderamin is probably a great aunt and Denebola a first cousin. We could also include Deneb Algidi or Delta Capricornus in this list, which is another A-type star in the local vicinity, although we're not focusing exclusively on it for the purposes of today's video. In this table we see an overview of stellar ages of these stars. We must bear in mind that A-type stars typically live, as we've said, around 1 billion years on the main sequence, and we see that Alderamin, located some 49 light years away in the constellation of Cepheus in the deep northern skies, at 820 million years is actually coming towards the end of its main sequence life. Sirius, as we can see, by contrast is quite young, and Altair a relative baby, whereas Vega is pushing towards the end of its main sequence life too. Alderamin, the elder statesman if you will, is now showing signs of leaving this main sequence and indeed carries the designation of A74-5. And the 4-5 means that there are signs that the star is leaving the main sequence and beginning to swell into a red giant. Denebola, by contrast, the second brightest star in the Lion constellation of Leo, and lying some 36 light years away, is somewhere between young and middle-aged, and possibly slightly older, or even potentially slightly younger than Sirius. We're not fully sure at this point. In this table we see the star's relative mass to the Sun, and we can observe that Sirius, Alderamin and Vega are certainly the larger of these stars, whereas Altair and even smaller Denebola are the smaller relations. Altair's 88 million years, for example, as I say, make it a very young star, and this coupled with the star's slightly lower mass than the others in this list, you might actually expect Altair to live the longest of these 6 stars, both in chronological time and proportionally to its mass. So if life were to be forming in these systems, it might be fair to say that the best bets could be Altair and indeed Denebola, which although a little older than Altair is even smaller in mass. Less mass of course in star terms means longer lifespans, and certainly these two stars should live longer than their more massive counterparts. Indeed, potentially Altair and Denebola could even live as much as 400 to 500 million years longer on the main sequence than the more massive Sirius or Vega, if they're lucky. Of course, if either Alderamin or Denebola were closer, they would obviously shine brighter, but their further distance from the Sun leaves Alderamin with an apparent magnitude of 2.5, and the 88th brightest star in the night sky, whereas Denebola is slightly closer and also slightly brighter at 2.14 apparent magnitudes, which leaves it the 60th brightest star in the night sky. Like many A-type stars including Vega and Altair, both Alderamin and Denebola have oblate shapes due to their high rotational speeds, although this is much more pronounced in Alderamin, which is a faster spinning star. And also, this high rate of spin means that Alderamin has significant magnetic activity, whereas Denebola for its part shows delta Scuti variability, and this means that it experiences periodic changes in brightness due to pulsations in its outer layers. Both Alderamin and Denebola are also easy to see in the northern hemisphere, although it might be tricky to see Alderamin in the southern hemisphere as it is a circumpolar star, and indeed, interestingly, very much like its cousin Vega, Alderamin will become the North Star in the not too distant future, universally speaking of course, in the year 7500 AD, keeping a place warm for Vega, which will then take over in 14500 AD, after a brief interlude by the star of Pharaohs. Denebola for its part forms one part of the Spring Triangle, which includes the stars of Spica and Arcturus. We see here the stars compared together, and interestingly Alderamin has a luminosity 17 times that of the Sun, whereas Denebola is somewhat dimmer at 12.9. This leaves Denebola intrinsically brighter than Altair, but dimmer than its other A-type counterparts. That said, perhaps the most interesting thing about Denebola is the star's circumstellar disk. The star shows a strong infrared excess, which indicates the presence of a circumstellar debris disk. For those of you experts out there, you might think that this is much in the same way as the star of Vega, and indeed Fomalhaut, very famous for having circumstellar disks, and it certainly seems common amongst such stars. The presence of such a debris disk suggesting ongoing planet formation within the Denebola system, and indeed the star's middle age, seems consistent with active planetary system development and disk evolution. So what this means, of course, is that life could yet to become for the Beta Leonis star, although as always with A-type stars, it better get its skates on because the clock is ticking. Of the 6 stars, only really Altair is still in its infancy, so Altair has time to get its act together, assuming of course that it's not already done so. We see in this next diagram that of the A-type stars, it's the dog star of Sirius that is the bluest, whereas Altair the yellowest of the stars in the local vicinity. Alderamin for its part is quite yellowish, as you might see, and again you might expect this for a star slowly leaving the main sequence. Denebola on the other hand is almost perfectly white. All the stars, relatively speaking of course, though, are white in colour. As we see, if we actually compare them to other stars like the G-class Sun, they do appear very white indeed. In today's final graphic, we imagine a scene around the Uranian moon of Titania, and joining the Sun over the centre of our solar system. First we see the star of Denebola appearing, shining brightly at plus 23.19 apparent magnitudes. Titania lights and warms up, and slowly the even larger and brighter, and indeed slightly yellower Alderamin develops, shining, almost 1.5 times brighter now than Denebola, at plus 23.5 apparent magnitudes. Both stars overpower our Sun, and indeed make a very toasty day on Uranus's fragile moon. Denebola and Alderamin are 2 close-by A-type stars that could be thought of as close relatives to their more illustrious and famous neighbours of Sirius, Vega, Altair and Fomalhaut. Alderamin, or Alpha Cephei, is coming towards the end of its time on the main sequence and is thought to be developing into a red giant, and accordingly has a more yellow tinge to it. Denebola, or Beta Leonis for its part, is somewhat similar, but remains a more powerful star than Altair, and like Vega and Fomalhaut, is thought to have a debris disk surrounding it where planetary formation could be happening on this very day. Shining brightly in our skies, and relatively simple stars to find in the night sky, these 2 white A-type stars are fascinating to consider. And who knows, one day in the far future perhaps humans will visit, before the stars exhaust their hydrogen core fuel and expand into giants. Thanks for watching, and consider subscribing if you haven't already. If you would like to support the channel further, you could consider joining the channel or alternatively buy me a coffee, and I'll link this in the description. Many thanks to those of you who have already done so. Take good care of yourselves, look after your friends and family well, and I'll see you on the next one.